All right, guys, so welcome to section 8.2. We are working with similar polygons. So I know that we've been working with congruent triangles, congruent polygons, congruent shapes. A similar polygon is, let's copy this and paste this so I can show you guys, is something that is the same shape but a different size. So you can see what's happening here. It's the same shape but a different size. So it's either going to be larger or it's going to be smaller, okay? We call it a dilation, and the dilation is either going to be an enlargement, or a reduction. There we go. And so the shape is either getting larger or it's getting smaller, but again, it is staying the same shape. Okay, so it's getting larger or smaller, but staying the same shape. When this happens, so when you saw me copy and paste this and make it larger and smaller, you can see, look at the angles. Do you see how this angle still fits in there? This angle still fits in there, and this angle still fits in here. What happens is the angles actually stay congruent. So obviously the angles inside of a triangle are always going to add up to 180. So if this angle was 50 and this angle was 60 and this angle was 70, it would remain the same no matter how big or small I make the sides. Okay? What happens to the sides is the sides actually become proportionate. So again, if I cut out my shape and kind of move it over here, hypothetically, if this side was 5 and I blew it up twice as big, this side would be 10, which makes if this side 6, this side would be 12. If this side is 4, then this side would be 8. Okay, so once again, the sides are proportionate and the angles are congruent. Okay, again, it's either an enlargement or a reduction. So that's what we're working with. So you guys are going to be seeing this symbol from now on, and this symbol just means similar. Okay, so I know that we've been working with the congruent sign, which is both equal and similar. So this means congruent. Okay, whereas the other symbol means similar. So if I were to tell you, and this is huge, guys, if you see something where it says, you know, A, B, C, D is similar to E, F, G, H, then you have a lot of information, even if we don't have a picture. Okay, what this information tells me is that angle A is congruent to angle E. Notice that they are first in line. Okay, again, you know what? Let me erase this because I did it alphabetical. Let me pretend it says something else. ABCD is similar to FGHE. What this tells me then is that angle A is congruent to angle F. Again, I have no picture, but because the A is first and the F is first, it lets me know which angles belong together. So if this was accompanied by a picture, okay, so let's say it's ABCD, and the other picture, again, is somewhere over here. And it's, let's say it says, you know, FGHE. What this tells you, this right here, called the similarity statement, is which angles can belong to each other, which angles are congruent. So this tells me that angle A, again, because it's first in line, is congruent to angle F. It also tells me, again, because they're in order, that angle B is congruent to angle G. So you can see how this shape was kind of flipped around. Of course, my drawing is not the best. It tells you that angle C belongs with angle H. And then lastly, angle D belongs with angle E. All of those angles are congruent to each other. Okay. This similarity statement also tells me which sides are proportionate. Okay, so again, you can pick out the proportionate sides, and you do that again in order. So side AB, over here, is proportionate to side FG. Okay, that proportion, because these are similar, that proportion is going to be similar to side BC over side GH, which again is equal to side CD over HE. And lastly, that is similar to, which color haven't I used? AD over FE. Okay, so a couple things. Again, this is called my similarity statement. I left my Apple Pencil at school, guys. Sorry, it's loud. That this right here is called my similarity statement. This is the key. Okay, this tells you which pieces kind of go with each other. This is called a statement of proportionality. Statement of proportionality. It tells you the proportions of each of the sides. And again, those ratios have to be equal to each other. Okay, you can see that up here. If I were to actually put these over each other, 10 over 5 is equal to 12 over 6, which is equal to 8 over 4. So all of the sides are proportionate. They have the same ratio when you reduce them, and all the angles are congruent. So that's what we're working on in Chapter 8, are these similar polygons.